All right, so we need to add these expressions, and in order to add, it must have a common denominator. So here, right now, as is, these do not have a common denominator. So what we want to look for is the least common multiple, which is the smallest thing that we could multiply each of these by to get them to be the same. So here, 6 and 2, the least common multiple would be 6. You can multiply this by 1 and this by 3. And the least common multiple for our variables would be x squared. So we can multiply this side by x and this side by x squared. So our goal is now to get the denominators of both of these to be 6x squared. Well, how do we do that? Over here, we have to multiply by 3. If we multiply by 3 on the bottom, we also have to multiply by 3 on the top. So over here, we're going to do 3 times 3 is 9. 2 times 3 is 6x squared. And over here, how do we get this to be x squared? Well, we need to multiply by an x. So if we multiply by x on bottom, we also have to multiply by x on top. So now we have 5x on top, 6x squared on bottom. So now that these have a same denominator, we can now add the tops. So the top becomes 5x plus 9. The denominator stays the same. At the end, we would try to simplify this, but there's no GCF that we can factor out of the top. So there's nothing on the outside but parentheses that we can cancel. So this would be your final answer. And if it asks you to state for an excluded value, make sure you state the excluded value. In this case, it would be x cannot equal 0. All right, over here, we also have two denominators that are not the same. Now, what could we multiply both of these by to get the same? Well, we're looking for the least common multiple. Here, there's nothing we can multiply by to get this, vice versa. And we can't multiply by m, because that would give us m squared plus 2m over here, and m squared minus 7m over here. And then 2 and 7, the least common multiple would be 14. But if we multiply in 14, we get 14m squared plus 2. Or if we multiply this side by 7, we'd get 7m plus 14. This side, if we multiplied it by 2, we'd get 2m minus 14. So that doesn't work. So the least common multiple here is actually the product of both of these, m plus 2, m minus 7. And it's kind of like if you had a denominator of 5 and 7. So let's say if this was 9/5 plus 9/7. There is no multiple in common here. So you would have to multiply this by 7 over 7 and this by 5 over 5. Well, the same thing goes here. There's no common. So our common is going to be both of them multiplied together. So over here, we're going to multiply by m plus 2 on top and bottom. And over here, we're going to multiply by m minus 7 on top and bottom. So our denominator is going to be our least common multiple of m minus 7, m plus 2. It doesn't matter what order it is in. On the top, now we have 9 m minus 7 and 8 m plus 2. And when we add those together, we get 9m minus 7 plus 8m plus 2 over m minus 7, m plus 2. You see that these cannot cancel since this whole top piece is addition. So we would go ahead and distribute these out to put it in standard form. And we get 9m minus 63 plus 8m plus 16. And then if we combine like terms, we get 9m plus 8m is 17m. Negative 63 plus 16 gives us negative 47 over our denominator m minus 7, m plus 2. So that would be our final expression. Actually, if we want it in standard form, we would also have to distribute out the bottom. So it wouldn't quite be final yet. It'd be m squared minus 7m plus 2m would be minus 5m minus 14. So our actual final expression would be negative 17m over 47 divided by m squared minus 5m minus 14. And if it asks for excluded values, we would have to go back to the beginning, and our excluded values here would be -2 and +7. So that would be our final answer. If it asks for it in factored form, you could keep it like this. Standard form, we would keep it like this.